Hello, in this video we're going to look at proving the derivative rule for polynomials. So that's where we multiply by the power and then we subtract one from that power. So to access this video you're going to need to be familiar with binomial expansion, and if you're not, I'll link my video on that in the description so you can go and watch that video, then come back and see this one. And if you do find this video useful, then please do go over to my channel where I have loads of other maths tutorials. Okay, so you can see I've already written down the definition for differentiation from first principles. And we are taking the derivative of x to the power of n. So let's just put that into our definition. So we get that the derivative f dash of x is going to equal the limit as delta x tends to 0 of, well, what is f of x plus delta x? Well, that's just going to be x plus delta x to the power of n. Minus f of x, well, that's just x to the power of n, and we're dividing all of that by delta x. Now, at this point, we might think that we're stuck because, well, I don't know what n is, so how am I supposed to expand this binomial on the numerator like we would usually do? Well, actually, we can expand this using our binomial expansion, and I'll bring the formula for that in now. So you can see here I've written the formula for binomial expansion, and so the way this relates is our value of a is just x, and our value of b is just delta x. Okay, and to make this really clear, I'm going to write that out below. So our value of a in this binomial expansion is x, and our value of b in this binomial expansion is delta x. And I'm literally just going to take this binomial expansion formula and use it to rewrite the numerator. So our derivative f dash of x is just the limit as delta x tends towards 0 of, okay, well, a is x, so it's x to the power of n plus n choose 1 of a to the power of n minus 1, which is just x, so x to the power of n minus 1, multiplied by b to the power of 1, which is delta x, plus, and I could do the next term, but I'm not because I could be here all day, so I'm just going to stop with the first two, and then I'm going to do the last two terms. So that's going to be n choose n minus 1 of a to the power of 1, which is just x, multiplied by delta x to the power of n minus 1, and then finally, the last term is b to the power of n, which is delta x to the power of n. So now we've expanded that binomial on the numerator. So then we're minusing f of x, so minus x to the n, and we're dividing all of this by delta x. Okay, so our derivative is now the limit as delta x tends towards 0 of this thing here. Well, you'll see these x to the n's cancel out on the numerator. And if you have a look, each term we're left with on the numerator will have a delta x in it somewhere, because the first term we're left with, this one here, that's got delta x to the power of 1, and in each subsequent term in this expansion the power is going to be increasing by 1, so the next term would be delta x squared, delta x cubed, all the way up to this one, and then finally delta x to the n. And so I could actually cancel out that delta x from the denominator with each one of these delta x's on the numerator, and that's going to give me this. So it's going to cancel in that term there, it's going to cancel in these terms up to the penultimate term, where it's going to change to delta x to the power of n minus 2, because one of them is cancelled out, and finally it's going to cancel out here and leave me with delta x to the power of n minus 1. Okay, so let's write that in. So we're looking at the limit as delta x tends to 0 of n choose 1 of x to the power of n minus 1, plus a lot of other terms, plus n choose n minus 1 multiplied by x delta x to the power of n minus 2, and plus delta x all to the power of n minus 1. Now in the limit as delta x tends to 0, all of the terms with a delta x in are going to go to 0, and we just get left with n choose 1 of x to the power of n minus 1. So how could we rewrite this to make it look like a more familiar form? Well, if you remember, n choose r, let me write this on the side, n choose r is actually equal to n factorial over r factorial multiplied by n minus r factorial. So I'm going to use this definition. So n choose 1 is just equal to n factorial over 1 factorial, which is 1, over n minus 1 factorial multiplied by x to the power of n minus 1. Now this part here, I'm going to rewrite the numerator, because remember, n factorial just means n multiplied by n minus 1 multiplied by n minus 2 all the way down to 2 times 1. And so actually I could write it as n multiplied by n minus 1 factorial. So let's write it like that. So I've got n multiplied by n minus 1 factorial over n minus 1 factorial, and that's multiplied by x to the power of n minus 1. Now these two things cancel out, and we get left with what we were looking for, n multiplied by x to the power of n minus 1. And you can see we've got the derivative of x to the power of n. Now this only works for natural numbers, because when we did our binomial expansion, we said that the only values of n we could expand for were ones that were natural, so positive integers basically. But this is true for all values of n, and later on when we look at implicit differentiation, we can prove that also. So hopefully this video was useful. If it was, do go over to my channel where I have loads of other maths tutorials, and thanks for watching.